So funny. Oh, I just love this show. But man, on this tiny screen, it's just not that much fun. Hang on a second. Oh yeah, this is way better. It's almost like watching on the big screen. Wait a minute. I love this part. Oh, it's so hilarious. Oh, SpongeBob. Wait a minute. I could watch this on the big screen. Hold on a second. Now that's what I'm talking about. That's big screen funny stuff. Awesome. Love it. Alright, today we're going to talk about ratio and proportion. Like you saw in the intro, the ratio and proportion of different size screens is exactly what we're talking about in this section, because we're going to talk about writing and simplifying ratios and using proportions to solve problems. Different size screens actually talk about, like, aspect ratio and different things like that give us ideas of how big a screen could be. Okay, and so whether we're watching cartoons or movies or we're going to the theater, what we're talking about is using proportions to see different images. Okay, so we're going to write and simplify ratios and use proportions to solve problems in this section. A ratio uses division to compare numbers, okay? And ratios can come in three forms. We can write them as A over B, or A colon B, or A to B. It's important to remember that B does not equal 0, okay? Because B can't equal 0 because we can't divide by 0. Okay, so B does not equal 0. One example of a ratio would be comparing the rise and the run in slope. Okay, so we're going to scroll down to example 1, and we are going to write a ratio expressing the slope of line L. This is line L. Well, we remember that slope is y2 minus y1 over x2 minus x1, or rise over run. Okay, and so when we subtract, we get 3 minus a negative 1 over 4 minus a negative 2 is equal to 4 over 6, or 2/3. That is a ratio right there. 2 to 3 would be a ratio, or 2 over 3, or 2 colon 3. Okay? And so in this one that's highlighted here, I would like for you to try this one. In this case, I don't give you the graph, but I give you the 2 points. So write a ratio expressing the slope of line M. You can go ahead and pause right here. Okay? I am going to move on. A ratio could possibly involve more than 2 numbers. Okay? And so the ratio of the sides in this rectangle is equal to 3 to 7 to 3 to 7. Okay? That's the ratio of the sides in this rectangle. In example 2, when we use these ratios, we're going to be able to solve for the lengths of sides using this and perimeter. Okay? And so it's important to remember that we don't just have to have 2 numbers to have a ratio. Okay? The ratio of the side lengths of this quadrilateral, whatever it happens to be, is 2 to 3 to 5 to 7. Notably, it doesn't necessarily have to be side length 2, 3, 5, and 7. Because if it's a ratio, then it's a division problem, a fraction, so we'd have to reduce it. And so in this case, what we're going to say is it's really 2x to 3x to 5x to 7x. because if x is 1, then it's 2 to 3 to 5 to 7. But if x was 2, it would be 4 to 6 to 10 to 14. But that would reduce down to 2 to 3 to 5 to 7. And so if this quadrilateral, which has 4 sides, has a perimeter of 85 feet, what we're going to say is 2x plus 3x plus 5x plus 7x is equal to 85, because regardless of what x is, it's all going to add up to 85 when we get done. Okay? And so when we combine like terms, we get 5 plus 5 would be 10, so we get 17x equals 85. So therefore, x equals 5. And when it says what's the length of the longest side, well, this is going to be the longest side here. So it's going to be 7 times 5 is equal to 35 feet for the longest side. Okay? So you see we compared the ratio of the sides and used that, formulated with an x, to find the perimeter, to find what it would equal to when it was equal to the perimeter. Okay? I want you to try this one in yellow here. Remember, we're talking about the angles, but we know what the measures of all the angles of a triangle are supposed to be equal to. Okay? So don't forget that. Let's move on to talk about proportions. In a proportion, really what we're talking about is two fractions that are equivalent. So we would say two ratios are equal. Okay? And so, for example, it might look like this. You've seen this before, like A over B is equal to C over D. Well, what we would call A and D are the extremes. That's just what we call them. And then B and C those are called the means. Okay? Now, when we talk about multiplying this, we're going to use the cross products property. So we'll have A over B is equal to C over D. And what that's going to give us, as I rewrite this because it was fairly sloppy here, this is going to give us a multiplication problem. Some of you have probably done this before. I would wager to say that all of you have done this before. We would call it the butterfly effect or the Jimmy Neutron effect, keeping with the cartoon theme. And we would say that AD is equal to BC. Okay? So this means that B and D cannot equal 0 because we can't divide by 0. Okay? And so these are called cross products. Because we look across the fraction to find those products. Okay? In example 3, we're going to use these to solve. Well, we see pretty clearly that when we make these circles, we set them equal to each other. So 45y is equal to 5 times 63, which would be 315. And we'll divide by 45 on both sides. So we end up with y is equal to 7. So 5 over 7 is 45 over 63. That's what they reduce to one another. Okay? A little bit more complex example that we might have seen before, maybe in an algebra class, is we have some expressions, some binomials. And so we have x plus 2, and that's squared because it's x plus 2 times x plus 2. So x plus 2 squared is equal to 6 times 24. Let's do a little bit of math before we FOIL this out. So we've still got x plus 2 squared is equal to 144. Well, look at what happens here, guys. If we say that we know this is squared, to undo that, I'm going to take the square root of both sides. Okay? So I end up with x plus 2 equals 12. So x must be equal to 10. I just did a little math. You could have FOILed that out and done quadratic formula and found all these things. Okay? And so what it's important to remember is that this is going to be x plus 2 is equal to plus or minus 12. Okay, so this was if it was positive 12, but what if it was negative 12? We'd have x plus 2 is equal to minus 12, so we'd subtract 2, so x is equal to minus 14. So we actually have two answers here, right? Okay, and so we have that little dichotomy that happens there. Okay, this highlighted example, I am going to scroll up and leave this top one here for you to do. Notice you have a very similar situation in C and D as you did in A and B, so solve those and bring those to class. We will talk about those. Okay, we're going to talk about the last thing here is a couple properties of some proportions. The proportion A over B is equal to C over D is actually equivalent to the following things. AD is equal to BC, right? That's the cross products. Okay? So when we talk about the cross products, this proportion is equal to this. Well, what it's also equal to, B over A is equal to D over C. Because look, the cross products are still going to be equal. BC is still going to equal AD. Another thing that it's equal to is A over C is equal to B over D. Okay, so all of these are equivalent. If we look at what this means for numbers, we could say 1 times 6 is equal to 2 times 3. So that means 6 equals 6, which makes sense. Or we could say 3 over 1 is equal to 6 over 2, which gives us 3 equals 3. So that checks out. Or we could say 1 over 2 is equal to 3 over 6. You can see with the numbers how this works out. And so what we're going to do down here is we are going to find what x and y are. We're going to find the ratio of x to y. So this is a ratio. Okay? And so if I look at what this means, 4x equals 10y, it sort of looks like this, right? And so I am going to reconstruct these two pieces here. So that means that 4 over, now A and B go together, so the first one goes with the first one, so 4 over 10 is equal to x over y. Well, that's actually really good for me because then I can find out that x over y is 2 over 5. That's really good because once I find that out, 2 over 5 is equal to 2 over 5 is equal to x over y. That's my proportion. Could be my side lengths, could be the ratio of my screen sizes if I'm talking about TV once again. Okay, and so that's how we solve these kinds of things. I'm going to scroll down. I'm giving you this next one. Okay? Remember, this T colon S is a ratio. And so I'd like for you to reconstruct this one and find the ratio of T to S. You've got one more example on this sheet of paper. We're going to talk about that one in class. So thanks for watching, guys. This should be mostly review, but remember, when we're talking about ratio and proportion, similarity, we're talking about screen sizes. So this is something we can really relate to. All right, thanks for watching. We'll see you next time.